All right, last section of chapter 4, 4.7 on bonding and physical properties. So how does bonding affect the properties of certain molecules and compounds? So there's three types of major compounds that we talked about. Ionic compounds, metals, and covalent compounds. So this is at room temperature and pressure. Ionic compounds are solids like salt, sodium chloride, copper sulfate. Their melting points, boiling points, and heat of vaporization are very high, so it takes a lot of energy to melt, therefore to boil and then to vaporize. Metals, ionic compounds are solids. They're strong ionic bonds. That's why they are solid. Their ions are holding them together. So a positive and a negative are close together, making a lattice, which is basically like a crystal. So you can see here it's a very good arrangement. Typical sodium chloride composition with a pattern of plus and minus. Very organized. High multi-point, boiling point, and heat of vaporization, so they need a lot of energy to overcome those electrostatic forces. Metals are solids, copper, silver, gold. And again, they have high melting points, boiling points, and heat of vaporizations. Really, the only time metals are not solid is if it's mercury, which is a liquid. They need high energy to overcome a sea of electrons. So remember, the metals have a positive and a negative sea that the electrons are moving very quickly. That's why they're good conductors of metals. They're free flowing of the outer shell. And it's a strong bond between those electrons and protons. And covalent compounds are very weak, therefore they're mostly liquid and gases, and their boiling point, melting point, and vaporization are very low. This is due to their intermolecular forces, which majority of covalent compounds are van der Waals forces. Some are hydrogen bonding, some are dipole-dipole. The very higher van der Waals forces, they are solid at room temperature, like iodine. Iodine's I2, it's a solid, but it does sublimate, meaning it doesn't go into liquid, it goes right into gas. That's because it's van der Waals forces. Here's an example of hydrogen bonding, which water is considered to be a strong covalent compound because of the hydrogen bond between H and O. Solubility in water. Ionic compounds are mostly soluble. There's a very few amount, particularly with the transition metals and larger molecules like carbonate and acetate, but majority are soluble in water. This is because of water's polarity. Water is electrostatic. It has a negative and a positive charge. The positive, partial positive of hydrogen and the partial negative of oxygen, and they will be attracted towards the positive sodium ions, and the hydrogens are attracted to the negative chlorine atoms. That's why salt dissolves, and majority of ionic compounds will dissolve as well. Metals are insoluble. You put copper in water, nothing really happens. Covalent compounds depends on the polarity. If you have a nonpolar substance, it's going to be insoluble with water. If you have a polar substance, hydrogen bond or a dipole-dipole bond, intermolecular force, they will be soluble in water. Example, iodine is not soluble in water, I2, because it's not polar, but hydrogen chloride is soluble in water, making hydrochloric acid, HCl, because of the dipole-dipole. Ammonia will be soluble in water because of the hydrogen bond with NH and water. Conductivity. Ionic compounds, if they're solid, they do not conduct electricity. But if you were to move it into a liquid, you have ions forming. And if you have ions, that means you can conduct electricity. So for example, distilled water, there's no ions present, it will not conduct electricity. Solid salt, again, they are in a crystal form, there's no positive negative charge, they're attracted to each other, so they are not conductive. But if you mix the two, you make a solution, now you have ions free flowing, causing electricity to move through. Metals, they do conduct electricity. If you were to, that's why you have copper wiring. This is because the delocalized free electrons are allowed to move freely, therefore electricity can travel through. As you can see here, you have a sea of electrons flowing every which direction, allowing electrons to travel. Covalent compounds, majority, well, almost all covalent compounds do not conduct electricity. This is because of their structure, and the really only exception is graphite, which is considered a metalloid sometimes because they do conduct electricity. The reason why graphite conducts electricity is because of its shape and structure. Here, a diamond is in tetrahedral shape. Tetrahedral meaning 4, remember. It's rigid, therefore electrons cannot move freely. But here you have, there's thin sheets of carbon, and it's not in a tetrahedral shape, it's actually a trigonal planar. This allows electrons to move up and down, forming a weak bonding force. That's why graphite is brittle, because of this force here, but they allows electrons to travel through because of the trigonal planar. Still a covalent compound, but again, it's weaker than diamond because of its structure. Trigonal planar for graphite, tetrahedral shape for diamond. Alright, so here's a few questions you need to have good explanations for dealing with. Think about their intermolecular force, think about the number of atoms, positive and negatives. For A, you have aluminum oxide, which is Al2O3, has a higher melting point, a lot higher than aluminum chloride, which is AlCl3, which changes to a vapor at 178 degrees. So explain why aluminum oxide has a higher melting point than aluminum chloride. Magnesium chloride conducts electricity when molten, but not when solid. Okay, you gotta think about ions. C, iron conducts electricity when solid, but solid iron chloride does not when it's solid. Think about structure of free electrons for iron. Sodium sulfate dissolves in water, but sulfur does not. So you gotta think about bonding. And propanol, which is an alcohol, has an OH on it, is soluble in water, but propane, no oxygen, is not soluble in water. One's actually a liquid and one's a gas. You gotta think about hydrogen bonding in that. And F, a solution of hydrogen chloride is in water conducts electricity, so why does hydrogen chloride conduct electricity? If you can answer these questions, you will have a solid understanding of how bonding works and intermolecular force.